Dixon from Queen Mary University of London. What has been your highlight of the conference so far?
Actually, a session I chaired earlier, organized by the pediatric track, or it was a pediatric track session on quality, economics and education in congenital heart disease, cardiac MR, which was really interesting. There were 3 talks. The first talk was about a quality improvement project undertaken in the US. Very interesting to define what actually quality is in cardiac MR and how you can measure process indicators and outcome indicators. So that was very, very interesting. And the second talk was about economics, so demonstrating the growth of cardiac MR in congenital heart disease, so showing that there's obviously lots of different reimbursement schemes, and that we basically need to understand how reimbursement affects cardiac MR uptake and use. And the third talk, which again is very important for quality in cardiac MR, was about the new education certification process in pediatric cardiac MR, organized by Oliver Tan, and he talked about how he set up the exam, which was run for the first time at this conference.
Fantastic. And I know that you have a research interest in big data, and particularly the UK Biobank. Would you be able to tell us a bit about that?
Yeah, I'm very excited about UK Biobank. It's one of the largest studies in the world. It has recruited about 500,000 people from the UK population between 2006 and 2010, and basically, you name it, has basically captured everything. It's got blood samples, it's got saliva, it's analyzed genetics, it's got biomarkers, it has weight measurement, body mass index, self-reported medical history, lots of things. It's also linking up with primary care data, it's linking up with hospital episode statistics, so we get very, very good detailed outcome data. And the exciting thing for us now is that we are well underway to scan 100,000 people from the original 500,000 cohort. So we've scanned 21,322 people, and we've pretty much analyzed the first 5,000 subjects scanned. And the exciting thing for me now is that we have lots of opportunities to answer research questions such as what is the impact of air pollution on heart structure and function and outcome, just to give you one example. But also we have options, and that's obviously a major interest here at the conference also, machine learning, artificial intelligence, deep learning. So I've been lucky to be involved with the UK Biobank data set to use that as a trained data set with labels, segmentations, and we now have seen that deep learning can basically within seconds analyze the hearts very accurately, both the left ventricle, the right ventricle, the left atrium and the right atrium, which should have major clinical impact because it shortens your time to actually analyze scans, and your reporting time should become faster, and you standardize your reporting between colleagues who might do it slightly differently. So I'm very excited about this. So machine learning, deep learning, I think is an exciting opportunity in cardiac imaging.
So is that where you see the field going over the next few years?
I think we'll see a lot of progress. So last year, I think it was, or 2 years ago, when Bob Balaban at the SCMR Conference mentioned drawing circles, this has got to stop. I think we can see that it's about to stop for certain things. There's lots more to do, but I think there'll be a lot of development in the next 5 years that will change how much time we need to spend with boring tasks in reporting. I don't think we become unnecessary or unimportant, but I think we can focus on the more interesting parts. I think that's important. I think also deep learning, artificial intelligence will have an impact on the time of image acquisition and image reconstruction. So I think we'll see the whole workflow actually from image acquisition to image analysis change.
Fantastic. Thank you very much. Enjoy the rest
Pleasure.
of it.